Did quiz 7 show up for you guys? And nobody told me about it.
I thought there was.
No, there's a quiz 7, and it's an important quiz because it's on the test that you have on Thursday. Oh. Test on Thursday. Or it's actually Thursday night, so it opens at midnight, closes Saturday night at midnight. Do not log on. If Saturday Night Live has started, don't log on and take that test. Send me a text and say, I'm sorry, I don't have time to take the test.
It's Saturday.
Saturday Night Live starts at 11:30. You don't take it all. Don't wait till the last minute to take the test.
The test due on Saturday.
It's due at midnight. It doesn't just close at midnight, it kicks you right out. Okay. All right. Am I recording? Can you hear me? Can you guys hear me?
Yeah, we can hear you.
Good. All right. Any other questions you have about the test? Life in general?
We can't see your screen though.
Okay, then you need to see the screen. You can see the screen now?
Yeah, thank you.
Okay, so I'm going to, for my online class, I've already sent them a link to the before the last test. I went over all the questions on I think pretty much all the questions on the test. They were all quiz questions, but they were also all the questions that were on the test. So I went over them and I saved that link. So if you want to watch that live stream again, I will send that out to you guys so you can see it. But also, you can just go to the live stream and see today's also. What am I going to go over today? So I'm going to go over some assignments. So let me go into mod 7 for a second. 7. So the first thing is some stuff out of order. Okay, there's the homework. The discussion, that's not. So there's only homework, discussion, analysis, and then there's that. So there's a couple things missing. The classwork is here. Okay, what is missing is the quiz. Let me just add something else first. Practice. Okay, so let me talk to you about the practice midterm all questions. That's what I did. You're going to have a midterm that comes up in this mod. It's going to be called practice midterm. And you're going to finish it before class on Thursday. Okay? And you're going to take it very seriously, like it was a test. Only there's no honor lock. Okay? And I'm going to go over it on Thursday. But that practice midterm is actually the midterm that I gave last year. Okay? Not last year. When I say last year, I mean over the summer. It's the midterm I've been using for a while, but I'm retiring it. So I'm giving it to you as a practice midterm. So by all means, do it. You get one shot at it. It's worth as much as a quiz. Each question's worth like 1 point or less. And they're all right or wrong. I will grade them, but I will grade them right or wrong. So the only way you're gonna get any credit for question if it's completely correct. I'm not breaking up partial credit because it's bad enough I have to grade them all. You only get one shot at it. Unlike quizzes, you can take as many times as you want. Take it seriously. Do not think you're going to get up and walk away because the clock is ticking. Okay? I mean, you can. There's no honor lock to tell you that you have to sit there the whole time. But if you use up the time, then use up your time. Okay? I'm going to put this up that's not available to you. Just put it up all at once. Okay. thing there. Okay. Let's take a look at this.
Is this practice mint going to be grade? It's going to be in our grade book?
The practice midterm is going to count as a quiz, I think. I don't think there's any place on the syllabus for it to sit. But I want it to count for something, so I'm going to count it like a quiz. And then I'll probably drop a quiz. Okay? Did that answer your question?
Yes, thank you.
No problem. Michelle. Okay. Oh, there's something else to know about this midterm test, by the way, the new midterm test. The questions, these instructions right here, the instructions that come up, I'm getting rid of them all. I'm just making a little link, okay, or a little paragraph, because I'm tired of sitting there. When you're sitting there reading those instructions, I'm sitting there waiting for you to decide to start the test. Okay, so we're just going to streamline that. So the instructions are going to be, if you need to see the instructions, fine. Otherwise, you don't need to see them. Okay. The same sorts of questions done the same sort of way. Okay. All right. Let's move on. Wait, where am I going? Oh, here are the questions. Question 1. What does Newton's method? Okay, and remember, these are not multiple choice questions. What does Newton's method find?
Find zeros.
Zeros. Keep it short, keep it sweet. Okay, what is 0 times infinity? Anything. Sure. Okay. Why did we invent limits?
To take the 2 points of average rate of change to the 1 point of instantaneous.
Very good. Okay, those questions, there will be 4 of them on your midterm. Okay, so these are only 3 of the questions that it grabbed at random. There are a whole bunch more. You know what they are, and you know where to find them. Okay, spend as much time. Honestly, if I were you and I was cramming right for this, I would just go through those at the last minute, try to keep them in your head. Okay, don't care how you remember them, just make sure you remember them and you answer them quickly. Okay. Again, the first questions you have to say them out loud, and they are timed, because if you're not saying them, oh, somebody yesterday was typing answers before they were saying them. There's a reason you don't type before you say them, is because I sit there and wait for you to type. Just say the answer so I can move on. You can type afterwards. Okay, you have plenty of time to answer the questions and write whatever notes you want down, but answer them first for me so I can go on to the next question. Otherwise, I'm spending a lot of time sitting there waiting for you. Okay. All right. The first questions are that way. The next group of questions where there are limits and derivatives and stuff. Again, if you write it down, it's going to take a long time. Just say it. So what does this one say? Acacia, can you read that for me?
The limit of f of x is x goes to approaches 1 equal -2.
That's it. Perfect. So the only other thing you might see with limits, look at question number 5. Okay, Selena, can you say question number 5? Selena there, hello. Otherwise, it's Eric. The limit. Go ahead, Eric. Start talking. The limit of
as x approaches 5. As x approaches 5, fx approaches to -6. Approach to -6.
Okay, so here's where you have to, there's that little plus means something. What does it mean? In
To
math, from the
on the left.
left is for the negative number side, the right is for the positive number side. That's what that little plus means. Okay? So it's from the right, Eric. All right. Number 6 is a limit also. The limit, this isn't hard. The limit is x goes to negative infinity. Okay, how about 7? So there will be a bunch of limits. And the, one will be from the right or from the left. It'll be minus infinity or plus infinity. The limits probably aren't going to be very complicated. How about the derivatives? How do you say these? Question 7. Jonathan, you want to say question number 7, or at least the first part?
Oh God. I don't know, honestly.
You okay? You don't know this notation d dx? What does that mean when you see d dx?
Isn't that the derivative?
Yes, and then what's
so-
the prime
the-
mean
So the derivative
of the?
f prime
You could
x.
just, that's right. You could just say that the derivative of f prime x. That would be
Okay.
perfect. But you could also say the second derivative of f, because those are two derivatives. That would make the second derivative. But I don't need you to know that. What I need you to do is say the derivative of f prime. Perfect. There's lots of ways of saying things, and they're not all correct, but if they're correct, they're fine. All right, Luke, how about the second one?
Just plus the second derivative of g at x equals 3.
Perfect. Well, you could say evaluated at 3, but yes. Thank you, Luke. Havani, last one. Oops, that one here.
I'm not sure, but h to the 4th times x.
Any to the 4th power here is wrong.
Okay.
It doesn't even start with h. It starts with the
Plus,
what?
I don't know.
That 4 represents what? Anybody? A lot of people got this wrong, so don't feel bad.
Derivative.
It means the 4th derivative. Thank you. So this starts off with, instead of starting with the h, you're starting with the 4th derivative of.
H.
All right, I'm going to give you a chance to redeem yourself. Do the next one. How about this one, question 8?
The derivative of f of x plus g prime 0 plus the fourth derivative of h times x.
Okay. 4th derivative of h of x, not times.
Oh, sorry.
Those little parentheses, we're doing functions, so those parentheses represent functions, derivatives, the value, the g prime of 0, you would say, not g prime. Some people say g prime times 0, and it's g prime of 0, or g prime evaluated at 0. Okay? All right. That's fine. I have another group that I'm going to ask. Pam. Pam, are you there?
Yes.
Do you want to help me with this one?
F prime of x plus second derivative of g of x plus fourth derivative of h of 7.
That's perfect. Or you could have said evaluated at 7, but that's perfect. Everything you said was great. Thank you. Slade, you get the next one. Oh, this is a hard one. Okay, Slade, what do we got?
The inverse of f of x dx equals I forget what the capital F is.
I'm glad you're saying that. So that first thing is the integral, not the inverse, but the integral. And so the capital F is just the antiderivative. So that's where you're thinking inverse, but you confused when you wrote the integral. You were like, oh, and you started with inverse, and that's not what it means. Okay? So that
Okay.
means the way you would say this is the integral of f of x dx is the antiderivative c. Okay.
Is this the practice midterm or is it the test for Saturday?
You know what this is? I don't know what this is. It's a culmination of quiz questions that I had. I thought it was, I wanted to go over all the quiz questions, and I think that's what this is. You should have seen all of these questions, but they're all the quiz questions from they seem to go all the way back to quiz 1. So I'm not quite sure, but it's a good review of the material. So some of the questions are duplicates because they were different questions on the quizzes. But I feel like this, I'm not sure where this sign came from. I just pulled it up as a review. It's not a bad review. Okay, did that answer your question, Alicia?
Yeah.
Or Keisha? Okay, good. All right, so now another note about the midterm. On the derivatives test, it was multiple choice. It was like A, B, C, or D. On this test, it's choose all that apply. So if you see more than one thing going on, you check it. So what's going on here? I see, okay, I see the derivative of 2x plus 9 is 2. That's just a regular derivative. It's none of these, particularly it's just a regular derivative. What's the next one? Equals the derivative of 2xy. What does that equal? All of this is that. Okay. And what would that represent? It represents one of these.
The product.
That is the product rule. Thank you. Does everyone see that? Product rule. You have an x and a y. So when you're taking the derivative of x, you just get 1. When you take the derivative of y, you get dy dx. All right. How about this one? That must be equal to all of this. So what do you see? I see the 3 came down and you subtracted 1, right? So which rule is that?
Power.
Thank you. And then what's this dy dx thing going on there? What's that? No. It's a chain rule. Remember, you leave the inside alone and then you take the derivative of the inside because the variables don't match. What's a chain rule? Implicit differentiation is just there to tease you because this right here is when you take the derivative of everything, that's implicit differentiation. But you're starting with that. That's not what I didn't ask you how you got here. I asked you how did you get from the first line to the second line. So no, this is not, implicit differentiation is not an answer, but the other 3 are. Okay. Any questions on that? How about this one? What do you think? I see a quotient, and then I see a bunch of stuff that looks like maybe it's the quotient rule. Is it the quotient rule? Did I do any powers? Did I do any chains? What did I do here? Okay, it's definitely the quotient rule, but is it more? Was there a product in here somewhere? It looks like the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. I didn't do any other derivatives. I just did the quotient rule. That's what the quotient rule says, right? So this is just a quotient rule. When you're working, I see there might be a power rule here because of these powers. When you do take the derivatives here, I see powers, but for this step, no. I don't see any products in here, and I don't see any chains. So that's it. This is just a quotient rule that will lead into a power rule to finish it up. Okay. Any questions? Okay, let's move on. How about this one? Oh, it's another quotient rule. Like, is there anything else going on in here? I see we're going to take the derivative of. There's definitely gonna be a chain rule, but there isn't now. Not yet. Okay. All right. How about this one? What do you see? Who can I call on?
Power rule.
There's definitely a power rule because there was a squared and the 2 came down, multiplied with the 4 to give you the 8, and you subtracted the power. Then you left the inside alone. Who does that? Which rule leaves stuff alone and then takes the derivative of it? The chain rule.
Chain.
I don't see any quotients or products. Okay, what about this one? I got a bunch of things. I have a term, right, in an equation, and then I have the derivative. Isn't xy just xy, x squared xy? Isn't that just xy to the 1/2 power? So I didn't really change anything. I did some algebra, that's it. Second one, I didn't change it all. Third one, I didn't change it all. I didn't really change anything except put the derivatives in front of every term. Which rule is that? Or what?
Implicit.
That's what it is. Differentiation. Very good. How about this one? Anyone?
There's a chain rule in there.
There is a chain rule in there. Because I left the
I
inside
also
alone.
see a power rule.
There's a power rule. No implicit, no products. Good. Any questions on those? So that's what you should expect. There might be more choices than 4, although I honestly don't think there are that many more choices than 4. There might be 6 choices. There might be, I don't remember. It'd just be 4. All right, any questions on that? That's your reading comprehension portion of the test. You don't, at least with these, you might get part credit if you're not sure. The other ones was multiple choice. You couldn't get any part credit, either got it right or not. A lot of people lost points. They were worth 6 points apiece on the derivatives test. Now they'll be worth 10 points apiece. This test has 20 questions and it's worth 200 points. So every question's worth 10 points, which is 10 points is 1% of your grade. So it's pretty, it really can make a difference in your grade. So try to do the best you can. All right. 17, calculate the following to the best field. So this is a limit. Okay, 4x squared minus 1. So there's a few ways you can do this. The first problem I'm going to have is if I try to copy this and paste it, it ain't going to work. So I'm going to have to remember it, 4x squared minus 1. So if I try to paste this, I get gobbledygook. The limit x to infinity is 4x squared minus 1 over the top. Oh, it's not so bad. Just have to read it. Equals fraction 4x squared minus 1 all over 2x squared plus 2x plus 1. 2x squared plus 2x plus 1. Okay. All right, so now there's a few ways we can do this. One way we can do it is just look at the graph. Where does it look like it's heading as we go to infinity? What number do you think it's heading towards? Anyone?
2.
It looks like it's heading to 2. Look at the y value, it's 1.96. Looks like 2. So you can look at it graphically. Okay. You could do it numerically. You can plug in f of 99999. There. Okay, so that's numerically. Or you could use L'Hopital's rule. Okay, so you take the derivative, the top, and you get 8x. And then you take the bottom, you get 4x plus 2. Now you take the limit as x goes to infinity, the limit, oops. Okay, what do I get? If if x is going to infinity, 8x is going to infinity. 8 times infinity is infinity. What's 4 times infinity plus 2? Infinity. So you can use L'Hopital's rule again. Okay, so what's the derivative of 8x? Just 8. What's the derivative of 4x plus 2? 4. What's 8 over 4? 2. Okay. I don't care which method you use. Whatever makes you understand that L'Hopital's rule is an application of derivatives. And it is on this test as one of the applications of derivatives, but you can use any limit, any way of finding a limit if you want. That's what it's made. Okay.
Professor,
Yes.
for the equation we just did, to write that down, would we do limit as x goes to infinity equals 2? Like, how would we write it?
Oh, we just this one just asks for an answer. If you had to say it, you'd say the limit as x goes to infinity of the quantity 4x squared minus 1 and quantity all over quantity 2x squared plus 2x plus 1 and quantity equals 2. But I don't generally ask you to present. Look, in this test, I love the questions at the end, the presentation questions where you have to say them, but that's for data sort of stuff. This is just a regular old thing. Okay, 18. Let's talk about this ellipse. Turn this one off. So here's the ellipse question. Okay. Find the slope of the tangent line of the point for the ellipse. So now understand this is not, it Desmos dropped the square, so I have to put them back up. Okay, so this is what I got. I got a nice little ellipse there. And I can see the point 1, 2, 1, 2 is right here. Right there. It's on the ellipse, right? And I could draw a tangent line to it. But let's find some stuff. So I have y in an equation where it's not solved, it's not explicit. So how can I find the slope of the tangent line? How do I find the slope of the tangent line? What do I do to this? Take the derivative. Okay, I'm using that notation, Jonathan, you see, I'm using that notation. Just means take the derivative. All right, what's the derivative of 5x squared? What is it? 10x. Excellent. What's the derivative of 4y squared? Take y. And then the derivative of 21 is 0. So now when I go to plug in the 0.12 into this equation, I have a problem. I plug 1 in here, right? And I plug 2 into there. And I get a false statement. 10 plus 16 is 0. That's not true. Something's missing. The problem is I know the derivative of 21 is 0. I know the derivative of 5x squared is 10x. But this derivative, these variables don't match. And when they don't match, you use what rule? Bring the 2 down, multiply by 8. Did the power rule, but then that y, that you left that alone, and then you end up taking the derivative of it. Okay, so you need to have that in there. That's what you were saying. I just wanted to show you what happens if you don't. So now if I want to solve for that, I have that. So now I just have that equals negative 10 over 16. Okay, now to check it, that's all, that's the answer. I can submit that. Or if I want to reduce it, I can even let Desmos reduce it for me. It's the same as minus 5/8. Okay. But what if I want to see it? So I can go up to my formulas and pull the line out. This is the one that I want. This one here. This is the equation of a line. Okay. I know the x value is 1. The derivative, sorry. Do I have a function here? No. I don't. So I just have to put the y value in. The y value here is 2. The x value, the a is 1, and then you want the derivative of 1, which is what we just figured out was minus 5/8. Does that look like the tangent line? Does it? It sure does. Okay. Okay, if I was off by a little bit, 5/9, it wouldn't look like a tangent line. If you zoom in, you would say, oh, it looks like a tangent line, but it actually sure does look like a tangent line. So you see how it bulbs out like that? That's a secant thing. That's not right. Okay. So distance, it might look okay. Doesn't look okay. Anyway, if you're taking this test and you think you found it and you say the answer, and I want decimal places, so I want this 0.625 because I think that's what the question says. Give your answer decimal, give the decimal to 0.625. If you're not sure how many decimal places to give or whatever, just give what you have. I'm not picky about how many decimal places there are. Okay, if you had the right work, you had the right answer, and you chose the wrong number of decimal places, or it said to, I virtually never take off points for that. But you do make me look at the problem. If you get it, if you put the wrong number of decimal places, I will definitely look at that problem. And if I'm not happy with the work you've done, then that's a risk you take. Because I don't generally, if you get these problems right, I generally don't look at them. Okay. But if I look at them and I find out that you just remembered an answer, some students remember an answer. I try to change the questions, and since you're going to take a new test, you might not find that that's useful at all. To change the answers. So you can't remember an answer. Okay. Alright. That was an application of derivatives and it was called implicit differentiation, yes. This is another one. A local linear is another. Here's the local linear approximation functions. So they want this one. I thought I had here before, but I got rid of it now. So I'll just retype it. The local linear that was in the formula sheet said L of X equals F of A plus F prime of A times X minus A. Oh, capitals. Okay, that's a local linear. Use a local linear approximation to find the square root. What's the function being done here? What is the function? The job. A function is another word for job. What's the job being done here? What do they want? The square root? That's the 1/2, or the square root of X. Okay, that's the job that's being done. Let me turn these off. Okay, that's the job that's being done. If you want the square root of 7, you write F of 7. That's the square root of 7, right? Uh-oh, there's too many variables. Is there another F somewhere? Hold on. Here it is. Change this. Okay. So there's the square root of 7. If you put that in, you get it wrong. Because you didn't use local linear. What is local linear? Well, you're going to take the line and you're going to take F of A, and you're going to add the derivative of A, and they tell you what A is. A is 9. So if I just add the slider, hello, put a 9 in. To see how that's a nice tangent line? Look at that. Nicely done. The red is the tangent to the blue. Now all I have to do is do the local linear of 7. Are they close? Yes. The answer is 2.66 or 2.667. Okay, it's not 2.645, whatever. That's the exact answer. This line is the exact answer. This line is using the local linear approximation centered at 9. Okay. Any questions on that before I move on? I really like this question. I do. I like it. If it doesn't show up on your test, I'll be disappointed. Okay, suppose the state income, blah, blah, blah. Okay, it'll be easier for me. I can copy the whole question, but it's easier for me to notice that this 0.12x, I'm going to end up plugging in then that number 19,600 into both of these 0.12x and to this. So let me copy this over. Right. Yeah. So what do you think? I have to take the 0.12x. And I have to take this right here, b plus whatever. Okay, and into both of those, I'm going to replace the x with 19,600. 19,600 copies. So I'm going to take this x and I'm going to replace it with 19,600. Okay, are you with me on that? I do not know what happened to my thing. Huh? Control. Okay, and then I'm going to do the same thing here. I'm going to plug 19,600 in here. And those should be the same value. Well, what happens when I plug 19,600? What's 19,600 minus 19,600?
0.
So that's 0 multiplied by 0.11, that's 0. So this whole thing turns out to be B. So if 19,600 times 12% is supposed to be the same as B plus 11% of this, well, that's all B. So what does that tell you? B equals 2,000. B equals 2352. Okay. So that's the answer, 2352. Okay, this is a chain rule. This is another one of my favorites. This one you don't have multiple choice on this test. So this question wouldn't appear in this format, but it says find the derivative. What do you do first with this? What happens first?
Don't you use the power rule first?
Power rule. So you bring the 9 down. 9 times 3 is what? 27. Is that one of our answers here? Yes, it's D. Okay. And then what? When you do the power rule, you raise it, you subtract the power, right? 9 minus 1 is what? Is that a number here? It is. It's 8. Where does that go? C. Okay. And then you leave the inside alone, right? So here's the inside. You have to leave that alone. Where does that go? What number? B or D? B. And then the last thing you do is then you have to take the derivative of the inside. What's the derivative of x to the 6th plus x plus 14? What is it? Which one? What's the derivative of x to the 6th? 6x to the 5th? There's a bunch of them. No, it's just f and g. Which one is that we want, f or g? What's the derivative of x? Either 1 or 0. What is it?
0.
No. 1, because the derivative of 14 is 0. X isn't a constant, so a derivative of it is 1. Okay, so there we go. That's that. So, okay. All right. Any questions on that? Questions? I like this question. It comes up. It definitely is a possibility. All right. This guy right here is an epsilon delta. This is an application of derivative. No, this is an application of derivative. This is the definition of limit. Ugh. Do that every single time. It's a definition of limit. So it's sort of important, but it's a dead-end topic. You know how to find limits. This just is a formalization of it. So what you have to do absolute value. Take this, the function on the inside, copy it, put it here, and then subtract the number 4. So you're taking the function minus the limit. That's what the absolute value said to do. Or that's what the epsilon delta thing said, and then say set it's less than epsilon. Like that. So it was the absolute value of f of x minus the limit. So it's just that part right there minus the 4. Okay, now you just have to take this and start working on it. So add the 1 to the -4 and you get -3. Okay? Take that 1/3 out. You end up with 1/3. Now you can't just make that 1/3 there, because if I distribute that 1/3, I'll get x over 3 and then I'll get -1. So this has to be 9. 1/3 of 9 is 3. Okay? Then you have to multiply both sides by 3. Okay, and you end up getting this. And you'll notice that 9 was in the limit. That was the other number that we didn't use. So you start with that function minus the 4, and you end up with the 9. Okay, which is the 9. And the answer that you want, though, is this answer over here, which is 3 epsilon. The answer is, you don't need the epsilon, you just need the 3. Okay, any questions on that? All right. Let's do this limit 6x to the third divided by e to the x. Okay, so what do I do? Okay. What do I need to get rid of these? Okay, is it L'Hopital's? I'm sure it is. Since it cannot define, so I can't, I have to do this. So I'm just gonna take a look at this function here. I'll call it h of x. Oh, you know, I tricked the other class too. I said, this is what happened when we. I said, all right, here's the function. What's it doing as x goes to infinity? And it looks very clear from this window that it's going to infinity, right? Looks like it's going to infinity. But then when you zoom out, you're like, nope, that's not going to infinity. It's going up and then it's coming down. But if you do the limit, you end up getting equals, you end up with infinity over infinity. Okay, and now you can use L'Hopital's rule if you like. Okay, you do that. What's the derivative of the numerator? I need to do it this way, but what's the derivative of 6x? It's 18x squared. What's the derivative of e to the x? It's just e to the x. You're getting infinity or infinity, you can use L'Hopital's rule again. So what's the derivative of 18x squared? It's 36x. That's infinity. We use L'Hopital's rule again. What's the derivative of 36x? That's just 36. Okay, so that's 36 over infinity. What's 36 over infinity? It's not, you can't use L'Hopital's rule for that. It equals what? $36 divided by everyone in the world. How much do you get? No. Checks in the mail. Okay, but you could just as easily look at this graph and see that it's going to 0. You could literally follow this trail. It You can just go like this and see, oh, it's getting smaller and smaller and smaller and smaller. It's going to 0. See the y values are virtually nothing here. Okay, or if you want to, you can plug it in. You can plug in a big value, bigger, bigger. Didn't take long. Now it's 0. Okay. Any questions on that? Don't have to use L'Hopital's rule. Okay. Any questions? Roughly quiet. Okay. Determine where the graph. Okay, so let me take this function. So I'm going to need it. We'll post it. And I'll raise these up. Okay. And I want to know when, what, let me turn this one off. What am I looking for? Determine where the graph of that is concave down. F of x is concave down where x is greater than or less than a certain value. Okay, so there's the function. I don't even know what that is. That it? Let me put some 9s in for mine. Okay, that's a graph. What do you think? Is it concave up here? Is that concave up? Does it look like it's a piece of the letter U? Or does it look like it's the letter N? Anyone at home? Carlos? N. How about over here? Is that piece of an N or piece of a U?
U.
U. So somewhere around there, about -6 or so, it changes. And that's what you need to find. When did it change from? Where is it concave down? This is all concave down. How do we find that point? And what's that point called? And what is the point called where it changes from concave up to concave down? Anyone?
Is it an inflection point?
It is an inflection point. Thank you. And how do I find it? I say the second derivative equals what? Second derivative equals what? Hello? Second derivative for inflection point. I told you second derivative. Second derivative. I'm awaiting. Concave down. Inflection point is when it equals what?
At a critical point.
What?
At a critical point.
I didn't catch that.
At a critical point.
The inflection changes at the inflection point is when the second derivative changes from down to up, which down would be a positive number or a negative number. Down is a negative number. It has a maximum, but it's a negative number, and up is a positive number. What happens between a negative number and a positive number? What number is between a negative number and a positive number?
0.
Okay. I gotta give it a different function because it's. See how the graph, Decimal's just found it. It's right there. -5.5. Okay, but you're not asked for the inflection point. You're asked for concave down. When it's concave down, it's when concave down is when this is negative or less than 0. Does that look right all of this time? So the answer is it's when concave down when the x is less than the value minus 5.5. You can see it shows that region. It looks concave down there. Everything is good. Any questions on that? It's a very easy question. I'm surprised you guys took so long at it. It's a definite problem, though. I mean, it's a definite one that I put on tests frequently. Question like that. Okay. And that optimization and stuff is an application of derivatives that we're trying. Okay, this one's also an application of derivatives. This one, I'm not going to do it. I'm not going to drive it. I'm just going to. I'm just going to go right to the formula. I happen to memorize the formula because I happen to know that Professor Porter frequently asks this problem. And the formula, as I memorize it, is x prime plus y prime divided by the square root of x squared plus y squared. Comes from the Pythagorean theorem. So taking implicit differentiation with respect to time, it's related to a blah, blah, blah. Okay, let's just put those things in. Let's say 27 is x equals. No, 27 is a rate. So is it x or x prime? It would be x prime. Okay, and then 1/5 is x. Then we have y prime. Then we have y plus. So I just have to plug those in here. So I have to put in 27, 1/5. The other one is 71 3/5. And then I plug in 1/5 here. That's there. Okay, and there's the answers. Any questions on this related rate one? It's a socket wrench. It's its own thing. Related rates are all their own thing. It is what it is. If you don't get it, you don't get it. If you want to go through and derive it, if you have time to derive it, that's great. If you don't, memorizing formula is fine. If you make a mistake, well. Okay. All right, so now we're getting into what looks like presentation problems. Use the Desmos worksheet. So this is some sort of data of some sort. And they're asking us to do something about it. I'm going to have to open up a new worksheet. Okay, don't ever touch the data or the regression. Okay. This must be a mean value theorem problem. Let's see if that's what it says. Because according to the blank regression, between the 5th and 20th hours of travel, the mean value theorem is satisfied in the blank hour. Okay, so it's between the 5th and the 20th. So I'm going to have to use 5 and 20 as my endpoints. And then it automatically finds the average rate of change. Okay, and then I have the derivative is here. So what does the mean value theorem says? Oh, by the way, let's just get the regression out of the way. This is x to the 4th, so it's a quartic regression. According to the quartic regression. Okay. Between the 5th and 20th hours of travel, the mean value theorem is first satisfied in the length hour. So all I have is the average rate of change, just this one, and I have the instantaneous rate of change, just that one. When are they equal to each other? Can you guys give me an idea when that might be? The first time they're equal to, is this one? This is the first time. Minus 1.6. Is that the answer we want? Is that the mean value theorem? No, because it's between 5 and 20. It has to be a number between 5 and 20, so that number is no good. Is there another number? How about this one? 8.45, is that one okay?
Yes.
So that's the 8th. There's another one over here. 17, but that's not the first time it's satisfied. So 8 is the answer I'm looking for. 17 is just a different answer. Okay. Because so the average rate of change. So this is the average rate of change. Is the same as f prime of that number right here. 8.48 for that thing. Yeah, they're the same, very close. Any questions on that one? Calculate this limit. Okay, so this is the limit as this thing goes to 21. This one, I just click on it. And I want to know what's the limit as I go to 21. Is it 1,000? No. What about if I put a 1 in there? What if I put a 21 in here? This is the mistake that people make. They put 21 in and they get nothing. Because this is the data. Don't mess with the data. And you can go down here. There's the function. You could use the table and put in 21. That's good. That's up there. Or you could literally just glide yourself up to the point 20, like there, and then you would get it's 21. This is harder than just typing it in that table. But anyway, it's 119 is what it is if you want a whole number. Okay, so the answer is just 119. And if you were presenting it, it would be, and you had to do the units, it would be 119 miles. Limits are just values. There's no per anything. Okay. So this would be something like 119 miles. Okay. If you're going to data like this, that's one of those group 5 problems or the presentation problems. You have to make sure you put the units in. Use Desmos in this link to predict where the second derivative is zero. Any questions on that other one before I move on? So I'm going to click on this and it says predict where the second derivative equals 0. Second derivative equals 0. So I must want p prime of x equals 0. When did that happen? Oh, right there. What's happening there at 6.95? What's happening there? It's an inflection point. So we say fill this out. So let's fill it out. Predict it and give it as the point x equals 7. Oh, to 1 decimal place, 7.0. The one does in words, according to the, which regression is this? Cubic regression. So according to the cubic regression, what? There is a blank at the hour 7, or the hour that happens to the 7th hour. What's happening there? What's happening at that point on the graph? Not on the derivative, not on this, but what's happening on that graph at 7? It went from concave up to concave down. So what is there? What happens when it changes sign? It's at what?
An inflection point?
Thank you. Questions on that? Okay. So it's just another way. So Yeah, so you can see where the discussion stuff is starting to come in a little handy. Okay, in this Desmos, make the prediction at the 9th hour. Okay. 9th hour. Right, so. According to the, which regression is this? Oh, it's folded up. It's quartic regression. Okay, according to the quartic regression, what? And the 9th hour of travel. Okay, so I have to change that 12 to a 9. We will have gone how many miles?
563.
100 miles. Plus or minus
19.
2.9 miles. This represents a what percent error? Oh no, it's not there. How do I find it? Percent error. I take the derivative. Oh, what's this though? Oh, that's the amount of error. So how do I find the percent error? I just take the 19 and divide it by that, multiplied by 100, or I just expand it even further. It's already done for you. So this is a 3.5% error. Look, if you have to figure this out, error is kind of painful. Not painful, you just have to know what it is. You have to know why I picked 0.5. I picked 0.5 because the data was all whole numbers. Okay, if the data had been smaller numbers, then I would have smaller 0.5. Or if the numbers were all within 0.01 of each other, then I would use 0.01. And then to find the percent error, that's just a percent error. So that's the same formula they use in chemistry and stuff. It's nothing special. Okay, Desmos traveling example, 22nd hour. 22nd hour. So I just put in 22. Oops, there's a table here with numbers in it, but we'll put in 22. So I got 1271 and 171. 1271 and 171. Uh-oh. It's expecting the second derivative. How do I find the second derivative?
Expand the table out.
There you go, 41. Or if you wanted to, you could literally do second derivative of 22. And you get 41. Okay. Say the answer. Oh, so according to the, let's go back here. So I'm going to say, according to the quartic regression, what? At hour 22, what's happening? You travel how many hours? Travel how many distance? How far? At 22 hours, you traveled how far?
1271.24. So 2.
1271 is fine. Miles. And you're doing what?
Accelerating at a rate of 171.
Okay, what's the units? And it's not accelerating, it's increasing. Wow, you're really picking up speed, 171 miles per hour. And then what? Say the rest. And accelerating by how much?
40 miles per hour per hour.
Wow. Okay, very good. Nicely done. And that's that. That's it. That is what you will see on your practice midterm. something like this, and you have a chance to practice it. So please do that. Again, let me just say the practice midterm, I grade it. There's no saying anything. Okay, you just put it might say to say stuff, but I can't. You're not saying anything because you're not using honor lock. So you're just gonna do it. Whenever it says you're just gonna do it, write it down. There's spots for everything to be written down. Okay.
Do you think you could do one more question involving epsilons?
No. I can. I just don't think you need it. There's a very small chance it's even going to show up. I know you're panicking about it, but that epsilon delta one. All right, sure, I'll do it. Where was that formula with the epsilon delta on it? It's the last. Here. The epsilon delta problems all look the same. They look something like this. They give you, they look like this. Put it here. Just Control Z when I do that. Okay. Hold on. Okay, so what you have to do is literally you do an absolute value. And you take what's inside the parentheses. Or let me change it to a different, let me change the problem to something else. I'm going to change this to 2x. 2x. And change this to a 5. Change this to 3. 3, that would be 13. So what you do is you do an absolute value. You take this function right here, you take the function itself, function that you're taking the limit out. You subtract the limit, which in this case is what? What's the limit?
13.
13, thank you. And then you have to say it's less than epsilon. Okay. And then you have to do some algebra, that's all. Copy. It's here. Take the 3 away from the 13. What do you get? 10. Okay. And then what can I factor out of there? What can I factor out?
The 2.
And see, when I factor it out, the number that's left should be that number that you're taking the limit to, which is 5. Okay, fine. Then how do I get the 2 to the other side? I just divide both sides by 2, right? Yes. Divide this by 2. Epsilon over 2. So what's the answer going to be here? What do you have to multiply it by? What do you have to multiply epsilon by? So the answer here is just going to be 1/2. Okay. So the answer is 1/2. All right. That's the only question I say. I don't spend any more time on that because that's a low probability question. Okay. All right. Any other questions on this? All right. I could save that link for you, but I wanted to do now what I want to do. That's pretty much every question on that assignment, and that's a lot of quiz questions. Okay, there's things that are on it that maybe, let me just show you some of the questions you might not see on it. And then I'm gonna go over to something else. Okay, so this was, where is that? Here's some of the things you didn't see. All of these. What does Newton's method do? What does Newton's method find? Quickly, answer them quickly. It finds zeros, thank you. Okay. What is an inflection point? Quickly. Luke, what's an inflection point? Inflection point is when the second derivative changes sign. Carlos, what's the mean value theorem say? Carlos. Did you guys walk away? All right, never mind. I'm just going to do them quickly because if you walked away, then you don't need to know what they are. What is acceleration? Continuity? What do you need for continuity? What are the limits? Why did we invent limits? What is math? What is 0 times infinity? Those are all perfectly reasonable questions, but just so you know, this test was designed to take 3 of those questions, and Blackboard is sometimes annoying and it takes 3 or 2 of the same question. So I'm not, I'm likely to break them up and pick specific questions. Not specific questions, but a smaller pool of questions. Okay, but that's a bigger pool of questions. All right, let's move over to quiz 7 then. That's another thing. Let's do. So now quiz 7 will be due on Thursday because you didn't do it today. Because nobody told me it was today. So let me just put it up first. To you, multiple attempts, unlimited number of attempts, take the highest grade, force completion. It's going to be Thursday, and listen, it's going to be Thursday at 6 o'clock. Finish it before class because I don't want you. I'm not extending it after class. I need you to be purposeful. I need you to be. First of all, I need people to be able to see the answers, which it won't do if it's still open. Okay. And secondly, I need you to be concentrating on the midterm. Okay, so now let's talk about this assignment that was down there and how to bring it up. Okay, so now quiz 7 is open for you. Okay. Should be right there. All right, so let's take a look at quiz 7. Just going to go in and I'm going to do quiz 7. What is maybe the most important application of derivatives? Ooh, that's a hard one. That's kind of an opinion. An application of derivative. Antiderivative, indefinite integral, when the x derivative equals 0 and undefined, that doesn't seem to be answering any question. None of those are particularly applications of derivatives. Anyone have an idea? Reduce the variables in a formula? Second derivative at a critical point maximum. What? Second derivative at a critical point is negative and at max and min, so that positive at minimums. That sounds like it's second derivative test. So what's the only thing here that's an application of derivative that just says application of derivative? Anyone? And it's probably the most important application of derivatives. Who haven't I called on? Pam. Pam. Which of these is an application of derivatives? We're using, yeah,
Optimization.
that's it. Optimization. Okay, you're actually using derivatives to answer a question, like what's the biggest, what's the best, what's the worst? Okay. Say the following. Slade, how would you say that?
The integral sine of x dx is negative cosine of x plus c.
Yep, that's it. And for the quiz, it's multiple choice, but very good. Sorry about changing the notation on this quiz, but I don't know. Okay. All right. So what happened here? Algebra, finding critical points, antiderivative, quotient rule, using a constraint, optimization with the second derivative test. Okay. So we want lines 5 and 6, but we can look at all of them. What's 5 and 6? What happens here? In line 5, the perimeter is a function of two variables, x and y. Okay? In line 6, it's only a function of one variable. So what did they do? What is this A right here called? It begins with a C. How about it's a constraint? So using a constraint to reduce a variable, or reducing the number of variables, we got rid of the y variable. You see that? Any questions? Let's take a look at the other ones. What happened here in line 2? They have a p and they took the derivative and set it equal to 0. What is that? Finding the critical points and optimization. Okay. How about this one? I see a function. I see the first derivative equals 0 and the second derivative is negative. So what might that be? Pavani, what might that be? There's a second derivative at an inflection point, not inflection point. A second derivative evaluated at a critical point is one of these. Do you know which one it is?
No, I'm not sure.
How about you guess? The second derivative is evaluated. To any of the
Last one.
optimization. Yep, that's it. That's the second derivative test. Okay. All right. Ooh. This one has a mistake in it. How about this one? Anyone? Alicia. What's happening here? First, D is a function of two variables. Now it's a function of one variable. So what has happened?
Can you go back and so I could see it? Well, which lines were they? 11 and 12.
Yep, 11 and 12. So I have the exact same thing, except where I used to have a y, I now have this x, 19x squared, which is listed here as a constraint. So what is it?
Are you reducing the variable with the constraint?
Yep, that's what we did. We used a constraint. But anytime you see the number of variables is dropped, that's what you're doing. Okay, how about this one? Here you can redeem yourself, Alicia. What's the answer here? It looks messy, but start focusing on what you see that's similar. This is A of W and R, and this is just A of R. So what happened?
So you're doing the same thing. You're reducing it with a constraint.
Yes, we are. Thank you very much. I don't know what's happening here in line 17, 18. It's just a derivative. Probably someone wanted to optimize it. Okay. 2021. What do you think? Sebastian, you're hiding. What happened here?
The 2021,
Yes,
the antiderivative.
that's it. Just the antiderivative. You see the plus C and everything. It's all pretty. Okay, how about this one? 23 and 24. There was an antiderivative and then it's still there. So the antiderivative was not done. What was done? But just some algebra. Does everyone see that? This was just some algebra. I distributed some numbers, no biggie. Okay, what about 26 and 27? What happened here? Yep, that's it. Very good. Antiderivative. Next one, 4. Okay, so let me talk to you about number 4. These optimization problems are hard to do on Desmos without scrap paper. Okay, it's not, it's not that they're hard to do. It's that they're, sometimes people ask me for scrap paper and I'd say no. And this would be one of the times where you'd say, no, you should let us use scrap paper. And what I would just say to you here is if you want, I don't want you to scrap paper, but I want you to see something. Oops. You can do it on Desmos, and you should be able to do it on Desmos because if you get this problem, then you don't need to draw a picture of it and stuff. You should have an idea of what's being asked of you. So this is the one with the box where you're folding up the corners. Okay, and you could start by saying volume equals length times width times height. With this box, since you're cutting corners out of each side, the length is no longer just the length. You can write it in terms of x. It's 93 minus 2x because we're cutting out 2 corners on each side. So we're taking the 93 and we're taking off the 2 x's. The next thing we're going to do is take the 23 and subtract 2 x's from there. And then when we fold it up, the height will just be x. So if this problem shows up on your test, you can't draw a picture of it the way I could right now because this is a Zoom thing. But you can picture this in your head. I'm cutting the corners out. So I'm taking 93 minus 2x, 23 minus 2x. When I fold it up, the height's going to be x. Okay? Somebody asked me why I can't let you use paper for these problems. If I let you use papers for this problem, I have to let you use paper for all problems because Unlock doesn't know how to do, it can't deal with that. So then Unlock's going to flag you for having a piece of paper the whole time. And so I don't want you to do anything on paper anyway. So try to write it here. If it turns out to be a problem, you can let me know. Right? Most people actually get this one. I've warned them that the word problems, the optimization problems are usually something I've already done and not something you have to draw a picture of. Okay. Anyway, how do I find the maximum? Oh, look, there's the maximum. It's right there. 5.3. Do you want the 5.3 or do you want the 54.15? Just find the x value that maximizes the volume. So you want which? What do you want? X equals. Okay, that's what you want. Any questions on this? Okay, just one other problem in this on this quiz that you'll get, which is the primitive problem. I'll find it. I'll get to it after I finish question 5. Question 5 is what's happening? Predict the number of cases in week 7 with the error. So this is an error question in week 7. Okay, so all you have to do is type in number 7, and you're going to say, according to the cubic regression, the number of cases is 431 plus or minus 47, and that represents a 10% error. Any questions on that? We kind of did one of these already, so I'm not too worried about that. Let me go back into the quiz and look at question 4. So here's the other quiz question that you might see. A 3-sided fence. The area enclosed is equal to 200 square meters. Find the total perimeter. Okay. Again, you can't draw this picture, but the picture is you have a river. You have 3 sides for a rectangular region. So that's X, this is Y. They're telling you the area is 200 square meters. So the area is XY is 200. Okay. So I'm going to do this. I'm going to take this sign and I'm going to say area equals XY equals 200. Or I could say Y equals 200 over X. Okay, now what's the perimeter? The perimeter of X and Y is 2X plus 1Y. Okay. I have 2 variables. How can I reduce this to 1 variable? Alicia, how do I reduce it?
You use the constraint.
This one, and I replace what? Replace Y with 200 over X? Okay.
Yeah.
Now, there's a picture of it. Let me just take. There's a picture of the graph. What am I looking for? A maximum or a minimum? Am I looking for this maximum here? Or am I looking for that minimum there? What's it say? Find the minimum total perimeter. Minimum. So it's here. So it's 10. The minimum is X equals 10. Oh, but the minimum perimeter is 40. Perimeter. If they ask for the dimensions, find the minimum total perimeter. Oh, that's it. It's just 4. Any questions on that? All right. Be prepared for either of those questions. Those are my favorite optimization questions. There's lots of, there were other optimization questions that were super easy. Like, where this one was a super easy optimization question. Find the maximum for this. You just have to click on the maximum. And the answer, whatever it is, 12. They give you a function, they say find the maximum. That's even easier than ones where you have there's no constraint here for you to worry about. Just a function of 1 variable. But optimizations can be that one. Okay. All right. I think I've gone over everything. You should be tired by now. Yes. Are we good? We've seen everything. This is due Thursday. This is not due at all. You don't get access to this. You're going to get access to what was the actual midterm.
We're not doing quiz stuff.
and quiz 7, they're both due on Thursday, and both due before class on Thursday. So that was quiz 7 that I just went over, do that. But so you have that, look, if you don't do it, you're just gonna get 0 on it. The same thing with the practice midterm. You don't do it, you're just gonna 0 on it, but it would be really good to do it. I will go over it on Thursday, but if the only people that get it, get the good, I'm probably gonna do the hard questions first. So if everybody gets an easier question, you might not even know that it's gonna be on the test. And that would be a shame because you might miss out on easy questions. So take the practice test. Okay. All right. Anything else? So I'm gonna set them up after you guys leave. I'll set them up so that they're there. Quiz 7 is already there, I think. Practice midterm will show up. So do that. So anything else that you would like to know between now and Thursday? I will go over those 2 assignments. No, I'll go over quiz 7, see if there's any problems still. We'll go for practice test, practice midterm. And then I will cover new material also that will not be on the midterm. But it will be mod 8. Mod 8 is super easy. Okay, there's no discussion. You're going to do your project. So all you have to do is put down what your project's going to be. And the topics, the homework and topics are very easy. They're all summations and sigma notation. And we're using Desmos, makes everything really nice and easy. Okay. All right. Okay, but you're free to go. Wait, no, don't go. Hold on, don't go anybody. Somebody's going to leave. I didn't take attendance, did I? So I have one more thing to do and then you can go. So, Slade, why are you here? I keep asking Slade this question. Slade, why are you here? Don't you dare tell me this is required. I was just talking to the dean about how you have to answer this question.
Yeah.
Waiting, taking too long. It's required because your program requires it, because you'll use it. Why? Because calculus is the study of,
Change to
and business is always,
changing.
there you go, good. Acacia, what are the 2 rates of change?
Average and instantaneous.
Okay. Garb, it's not here. Rudra's not here. Sebastian, what's the derivative of e to the x and natural log of x?
The derivative of e to the x equals e to the x, and the derivative of natural log x equals 1/x.
I know, I gotta change these, but all right, Pamela, what's the derivative of sine, cosine, and tangent?
Cosine, negative sine, and secant squared.
Very good. Jonathan, what does the chain rule say?
The derivative of the outside, leave the inside alone, then multiply by the derivative of the inside.
Pavani, what's the relationship between position, velocity, and acceleration? Pavani?
It's I think velocity's first and position is second.
Velocity is first, acceleration is second. That's fine. Alicia, what's the mean value theorem say?
Derivatives exist on AB, so that is equal to the average rate of change.
Fine, average equals instantaneous. Fine. Eric, what's 0 times infinity?
To anything.
Aiden, when can you stop your child school?
0 with 0 and
Selena, what's an inflection point? She's gone. She was here. I'll take 1 point away. That's generous. Luke, What are the critical numbers?
X values or the derivative is 0 or undefined.
Very good. Thank you. All right, now you can all go. Have a good day. Good luck preparing.
Good night.
Good night. Thank you.
7 will be easy. Practice midterm. Don't take it till you're ready. And then we'll talk about it on Thursday. Bye.
Thanks for hosting.
I'm off. Lights gonna go.
Have a good day.
Thanks, you too.